In section 11.7, we're going to talk about circles in a coordinate plane. Now, first off, let me tell you that a circle is not a function. A circle cannot be written as a function because it does not pass the vertical line test. Now, I'm going to first draw a coordinate plane to kind of show you what's going to happen here. We're going to derive our own circle. So, the center, I'm going to put as 0, 0. Now, I don't care where you put the point, but the point has to be somewhere around this circle. So this would be x, negative y. Any point in the first quadrant would be xy. Any point over here would be negative xy, and so on. So it doesn't matter where the point on the circle is because they're all equidistant to the center. So what we can do, though, is make a triangle out of each one. You can make a triangle, you can make a triangle, and a triangle. Because the radius is all we need. All of these represent r. So all we do, since we have right triangles, is use Pythagorean Theorem. Now it doesn't matter if we use xy or negative x, negative y, or negative xy, because when you square it in a Pythagorean Theorem, it will become positive. So we have x squared plus y squared equals y, or x squared plus y squared equals like c squared, but the c is the radius. So we get r squared. This is the basic formula for a circle. And we just proved it by using Pythagorean Theorem. This will always give you the location of the radius. However, that's only if the center of the circle is at 0, 0. What happens when it's not? So for example, in this case, we have a center point, h and k. Now, I'm hoping last year in algebra, you learned that h and k always told you the direction that something went. H always was left or right, k was always up or down. So all I need is the radius. Well, the radius in this case is just using distance formula. I want to know the location of r from the center. So I'm going to use the distance formula. Distance equals, we subtract our x values, so x minus h squared, plus y minus k squared. And now d is really the distance from the points, which is really r. So r equals all of this. And now I need to get rid of the squared. So I'm going to square both sides. We're going back to algebra. So this becomes r squared equals x minus h squared plus y minus k squared. I'm going to flip it around, and the formula is this. X minus h squared plus y minus k squared equals r squared. And this is how you find the direction of where your circle goes. R represents your radius. H and k represent the translations right and up or down. If h, for example, if you had this, x minus 4 squared plus y plus 1 squared equals 25. First off, the radius would be 5. And then here, minus 4, you should remember this from last year, minus 4 would mean the entire circle is shifted 4 units to the right, and this would be 1 unit down. It's the opposite, since, h right here, h is 4. So that means the center is at 4. And k is negative 1 because we have y minus k. So if I have plus 1, that means k is negative 1. So it's the opposite. I go right 4, down 1 to find the center. And from that center, my radius is 5 units. So here's our theorem. The equation of a circle with center hk is equal to this, which we wrote down, in which the radius is r. And I believe this is one of the only times we've ever done algebra, and I actually taught you algebra steps and a parent function and an equation, all that stuff all year. So write the equation of each circle. Pretty easy. We're going to do x. Now, the radius is 4. That means I have to do minus 4. I'm sorry, the radius is not 4. The center is 4. So that means I go right 4, which means x minus 4 squared plus y plus 2 squared, because I'm plugging them in up here, equals a radius of 3, so I'm going to get 3 squared, which is 9. So it's x minus 4 squared plus y plus 2 squared equals 9, and there's my answer. Circle B that passes through the point and has a center at negative 6, 3. Now you'll notice we don't have the radius. So our radius formula from up above was r equals the square root, and then we use the distance formula. It's just the distance. So the distance formula would be, let's subtract our x's. Negative 2 plus 6 squared plus 6 minus 3 squared. That's going to give us 4 squared, which is 16, plus 9. That gives us the square root of 25, so the radius is 5. Now we know our center is at negative 6, 3, so I just plug that in. X plus 6 squared plus y minus 3 squared equals r squared, which is 25. And that would be my equation. Really easy. All right, so the next part is actually graphing a circle. Here's the great news. We only need 2 things. Those 2 things would be the center and the radius. So now we have x squared plus y squared equals 25. Well, we haven't shifted the center. So the center is just going to be 0, 0. So we know we can put a point on 0, 0 as our center. Now from there, our radius is r squared. R would be 20, or r squared would be 25. So our radius is just 5. So we're going to go in 5 all directions. And this is where you just do the best you can at drawing a circle. And there will be a circle with a radius of 5 and a center at 0, 0. Our next example. First, we have to find the center. Well, the center is going to be at negative 1, 2. And we know the radius would be 3. So we go with 3 in all directions. And there would be your circle. So on a graphing calculator, how would you graph this? Because this is not a function, so you can't graph it by just plugging in x squared plus y squared equals 16. Well, what you would do is you would solve for y. So as you can see here, we subtract the x squared. And then we take the square root of both sides, which gives us plus or minus. So what you have to do is enter the positive root of 16 minus x squared and the negative root of 16x squared, and it would give you this value, and it would then make your circle. Example 3. Meteorologists are planning the location of a new weather station to cover Osceola, Waco, and Ireland, Texas. To optimize radar coverage, the station must be equidistant from the 3 cities, which are located on a coordinate plane at A, B, and C at those given points. What are the coordinates where the station will be built? So this gets a little tricky. Now I've already given you the answers in the bottom picture. But we have to, if we're equidistant, what are the coordinates where the station will be built? That means we have to find the perpendicular bisectors of the triangle if it's equidistant from all the points. So we're going to start with the bottom here. So this is 1, 2, 3, 4, 5, 6, 7, 8. So perpendicular bisector would be 4. So that's a really bad, let me redraw that. There's one perpendicular bisector. So now I'm going to cut the length of AC in half by finding the midpoint. So A and C, so the midpoint of A and C is, let's see, negative 3 halves and 3 halves. So negative 3 halves, 1, 2, 3. this would be negative 1.5, negative 1.5. So it'd be right there. Now I need to make it perpendicular. So I need to have a slope. So this is a slope of 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's a slope of 1. So I need a slope of negative 1. So it'd be this. And so the point I'll have in blue, the point's right there. As you can see, that's where it's located, is the midpoint. So we know A, the coordinates of the station, would be negative 1, 1. And then B asks, if each unit of the coordinate plane represents 8.5 miles, what is the diameter? Well, we just go straight across. The diameter is 1, 2, 3, 4, 5, be 10. Well, if each unit is 8.5, 10 times 8.5 miles would be 85 miles. So the actual region covered would be 85 miles.